This week we'll be looking at magnetic induction. So the learning outcomes are to understand how Faraday's law works in practice and to calculate efficiencies of basic transformers to see how Faraday's law works in a practical application. So part one, you'll be just dropping magnets through a coil to generate an EMF and measure this. So Faraday's law says the EMF is equal to minus the number of turns of a coil times by the magnetic flux passing through that coil in a given time. So the magnetic flux is just equal to the magnetic field that you're putting through and times A of your given area that magnetic field is passing through. Just note that the minus here in the EMF equation is to show that your EMF is induced to oppose the change in magnetic field. And so for part two, you'll just be calculating efficiency of different transformers with different core materials. So you're putting a current into your primary coil, which generates a magnetic field that is then passed to the secondary coil, inducing an EMF that opposes it. And you will see how the induced EMF changes with different core materials. Okay, so this lab's based on Faraday's law, which means if you pass a moving magnetic field through a coil, then you can induce an EMF. So that's what we're going to test with the first part of this experiment. So what you'll need is your two different magnets, which are placed inside these tubes, and they've got black and red to denote the poles. You've got your two coils, so the only difference between these two is just the amount of turns in each coil. And we've also got this differential voltage meter which plugs in and goes into the LabQuest to give us a reading on the computer. So when you're ready, you need to open up the Faraday Experiment within the Fundamentals folder. Okay, so when you're ready to drop, make sure the black end's facing down in your coil, and then hit record and drop. Okay, and you should get something like this. Okay, so for the second part of the experiment, you're testing a practical application of Faraday's law, which is a transformer. So what you're doing is you're sending a current into one of the coils. This is going to generate a magnetic field, and that, since it's an AC current, is going to be continually changing, and that magnetic field will pass through your secondary coil and will hence generate an EMF and pass a voltage into the second coil. Okay, so apart from your two coils, you will need cords to connect your circuit. You'll need two multimeters, which will act as voltmeters to measure the voltage in each coil. And you will need this, which is your iron core. So just for the iron bar part, it's just this bit on top. So you need to unscrew it from the rest of the transformer and just use this to place it within the two coils. And so it will look something like that. And then for the full transformer setup, you'll be placing them on their side through the core, and then screw the iron bar back on top, and this will be your configuration for the full transformer. Okay, so I'll just show you one configuration for the first transformer you're doing, which is the air core, so there's nothing in between the two. So you've got your power supply going straight into this first coil, which is your primary coil because it's receiving the power. And then we've got a voltmeter that's measuring the voltage coming across the two. Make sure that your voltmeter is set to alternating current voltage reading, which has a squiggly line. And then similarly, you've got a voltmeter attached to the secondary coil. So it's not actually attached to anything, but if you put it close to it, you should see that you're measuring some voltage because of Faraday's law. Okay, so a question that people sometimes ask is, why do you get reverse peaks in the first part of the experiment, and do they matter? So in short, the answer is no. It just means that you've switched the polarity that you drop your magnet through, or on the cables that you're measuring the voltage. So your first peak will still be the first peak that appears in time. You just won't worry about the sign as much. So that's the answer for that one. And secondly, a lot of people get errors due to not zeroing their readings. So when you get to it, you need to highlight a specific region and integrate it. And if you haven't zeroed your readings, then you'll be including an extra part into your integral, which isn't actually there. It's just an artifact. So make sure you zero, or in other words, calibrate your voltage meter before your recording.